Microscopes are basic tools of biology and other areas of science. This video introduces you to two types of optical microscopes that use light to help you see structures that are too small for the human eye. The history of microscopes dates back a long time. By 1250, magnifying glasses and spectacles had been invented. About 1595, Zacharias Janssen, with the help of his father Hans, probably produced the first compound microscope. In the 1600s, Robert Hooke used this microscope. In 1665, he published a book that showed the world organisms and details that had never been seen before. Over the last 4 centuries, many improvements have been made to light microscopes, but the main principles have remained the same. The general objectives of this video are to help students 1. Identify and describe the functions of the basic parts of a stereoscopic microscope, or, as it is usually abbreviated, a stereomicroscope. 2. Set up, adjust, and use a stereomicroscope. 3. Identify and describe the functions of the basic parts of a compound microscope. 4. Set up, adjust, and use a compound microscope, including oil immersion. 5. Calculate the magnification capabilities of a microscope. And 6. Estimate the size of microscopic objects. The simplest way of making an enlarged image of an object is to use a magnifying glass or lens. A single magnifying lens produces an upright or erect image that is enlarged 2 to 5 times. With 2 or 3 lenses together, a compound magnifying lens can produce a magnification of up to 30 times. However, as magnifications increase, lighting becomes problematic because the lenses become smaller in diameter and must be held closer to the object and the eye. Also, at higher magnifications, humans become too unsteady for clear observations. To increase useful magnification, humans have invented the stereomicroscope. Such microscopes are useful for examining such things as plants, insects, geological specimens, and electronic components. The next 2 parts of this video will help you learn to observe such objects with a stereomicroscope. Learning Objective 1. The learning objective in this section is to identify and describe the functions of the basic parts of a stereomicroscope. The base of the microscope is what holds up the other parts. It may be very simple or quite complex. The stage is where you place the object that you wish to view. The color of the stage may be important for you to clearly see the object. For reflected light, there is often a reversible stage plate. You can also place a piece of colored paper on the stage to change the background color. For transmitted light, the stage plate is usually frosted glass to diffuse the light evenly across the stage. In a stereomicroscope, a column or arm connects the stage to the rest of the microscope. The body of the stereomicroscope holds the lenses and focusing mechanism. Stereomicroscopes have only one focusing knob. With this knob, you move the body of the microscope closer or further away from the object. In all optical microscopes, enlargement of the image of an object is done by 2 lenses. The one nearest the object is called the objective lens. The one nearest the eye is called the ocular lens. In reality, each objective and ocular lens is usually composed of several lenses. Such additional lenses not only increase the magnification, but also improve the clarity of the image. To perceive an object in 3 dimensions, you must see 2 images, one in each eye. Also, each image must be viewed at a slightly different angle. Your brain then merges these 2 images into one image that has depth. Thus, a stereoscopic microscope has 2 separate light paths, one for each eye. The 2 ocular lenses for 2 light paths are obvious. However, the 2 objective lenses may be hidden. Changes in magnification are usually done in discrete steps by using different objective lenses. The lenses are often located in a sliding or a revolving nosepiece. Some microscopes have objective lenses with a cam mechanism that allows continuously variable or zoom magnification. Most microscopes today are designed to allow people to view objects while wearing eyeglasses. Keeping on your glasses maintains the visual improvements that they provide. Most ocular lenses of microscopes use rubber-like rings around them to protect eyeglasses from being scratched. Some of these rubber-like tops can be used to exclude extraneous side light for people without eyeglasses. These may be folded down for people who do wear eyeglasses. The distances between people's eyes are not the same, and so for stereomicroscope work, there has to be a mechanism to compensate. The distance between your eyes is called the interpupillary distance and is measured in millimeters. The usual range is between 50 and 70 millimeters. How to make your interpupillary adjustment will be explained later. Commonly, the right eye and left eye do not see equally well, even with eyeglasses. For binocular microscopes, you can adjust the ocular lenses for this diopter correction. How to do this will also be explained later. When microscopes were first invented, sunlight or oil lamps were the only sources of light available to illuminate what people wanted to see. Various devices such as mirrors and lenses were used to direct the light where it was needed. Today, nearly all optical microscopes use incandescent lamps for illumination. The goal of lighting for microscope work is to obtain bright and even illumination across the entire field of view. In some microscopes, the intensity and position of the microscope lamp is fixed. In others, the lamp can be adjusted in various ways. If a lamp is on a separate stand, it can be moved closer to or away from an object to change the amount of light reflected from the object. Moving a lens on a microscope lamp closer to or away from the light bulb can change the width of the beam of light. Some microscope lamps have variable transformers that regulate the amount of electricity passing through the filament of the light bulbs and hence the light intensity. You should always start off with the lowest setting and gradually increase it to the point that the object is clearly illuminated and is still comfortable to your eyes. When you are finished using such a microscope lamp, you should turn the transformer to its lowest setting before it is turned off so that the next time it is used, it cannot accidentally be put into a high setting and burn out the light bulb. Microscope light bulbs are expensive. If the object to be viewed is opaque, then light has to be shone on it and reflected back into the microscope. This means of illuminating an object is called reflected or incident lighting. Such lighting usually comes from above the object. A light source up high is usually the best for reducing shadows. If an object is transparent or can be made translucent by cutting it into thin sections, light can be passed through the specimen. This is called transmitted light. Transmitted light is supplied from below the object. Although it's difficult to hurt your eyes with reflected light, be more careful with transmitted light. Too much light can be painful or even damaging to your eyes. Also, the heat from lamps can burn you. Be careful when putting your hands anywhere near a microscope lamp. We have now come to the end of the first part of this video. The learning objective of this section was to identify and describe the functions of the basic parts of a stereo microscope. This included the base, stage, column or arm, body, focusing knob, objective lenses, ocular lenses, interpupillary adjustment, and diopter adjustment. We also looked at reflected and transmitted light.